For decades, we've kind of been sold this one story, that chemical fertilizers are the only way we can feed a growing planet. But what if that's not the whole picture? What if the real key to a healthier, more productive future is actually hiding in plain sight, right in our own organic waste? Well, today we're putting that to the test. Can compost really go head-to-head with industrial chemicals and win?
Right, so here's the core issue. We use chemical fertilizers to get bigger crops faster, and it works, but there's a catch. Over time, they can actually degrade the soil, stripping it of its natural life and leaving us stuck in this cycle where we need more and more chemicals just to keep going. It makes you wonder, is there a better way?
To really get this, we've got to look at the problem head-on, especially in places with really challenging conditions, like arid regions where farmers are dealing with poor, sandy soil. This stuff just doesn't want to hold on to water or nutrients, which makes growing anything a real battle.
Okay, think of it like this. Chemical fertilizers are basically an energy drink for plants. They give them a quick jolt, a direct shot of nutrients. But here's the thing, they do almost nothing for the soil itself. Compost, on the other hand, well, that's like a wholesome, nutritious meal that feeds the soil, rebuilding its health from the ground up for the long haul.
And that all comes down to this one crucial idea: soil organic matter, or SOM for short. This is the good stuff, the living, breathing heart of any healthy soil. It's like a pantry, storing up all the food for the plants, and a sponge, holding on to water so they don't get thirsty. The more SOM you have, the healthier and more resilient your soil is. Simple as that.
So how do you actually prove which approach is better? Well, scientists set up this absolutely brilliant experiment. I'm calling it the Great Basil Grow-Off. It's a straight-up head-to-head competition between all-natural compost and a big-time chemical fertilizer.
So the scene is a greenhouse in Morocco, and they're using that really tough sandy soil we were just talking about. And for our test subject, they chose sweet basil. Why basil? Well, it's super sensitive to soil quality, almost like a little diva. It was the perfect plant to judge this competition. And this was a legit by-the-book experiment. The team started with that poor sandy soil, split it into 6 different groups, planted the basil, and just let it grow for a full 90-day cycle. And then they measured everything. And when I say everything, I mean everything, from the soil's chemistry to how tall the plants grew.
All right, let's meet the players. First up, T1. That was the control group, just plain old soil. Then you had T2 through T5, which got more and more compost mixed in. And finally, T6, the reigning champ, which got a standard dose of NPK chemical fertilizer. Now, the one you're going to want to keep an eye on is T4. It's about to become the star of the show.
Okay, let's get to the good stuff. Round 1, healing the soil. Because before we even talk about the plants, we have to see what happened to the very ground they were growing in. This is foundational. And the change was, well, it was night and day. On the left, you see the original sandy soil. It was dense, heavy, and it would dry out in a second. But look at the compost-amended soil on the right. It's light, it's fluffy, and it holds water like an absolute champ. This is what adding life back into the soil looks like.
Now, check out this chart, because this is wild. Look at the bar for the chemical fertilizer. After 90 days, the soil organic matter is pretty much the same as the control group. Basically, nothing happened. But the optimal compost treatment, T4, whoa. It boosted the soil organic matter to a massive 13.71%. That's not just an improvement, that's a total transformation. It's a game changer. So the takeaway from round 1 is crystal clear. Chemical fertilizer is a short-term fix that feeds the plant. But compost? Compost rebuilds the soil for the long run. It creates this healthy, living ecosystem that can support life season after season.
Okay, so the soil is way healthier. Awesome. But here's the million-dollar question. Did it actually help the plants grow? Let's dive into round 2, the harvest, because this is where it gets really, really exciting.
It turns out there was one clear winner among the compost groups. That T4 treatment, the one with 30 tons of compost per hectare, that was the absolute sweet spot. It created the perfect home for that basil to just take off.
Let's talk yield. Check this out. The basil grown in that T4 compost produced an average fresh weight of 213.4 grams. That is a seriously hefty, productive plant. And they weren't just heavy, they were tall. The T4 plants shot up to an average height of 42 centimeters. You can just see the vigorous, healthy growth powered by that amazing soil. But it's not just about size, right? It's about quality. And for a culinary herb like basil, that all comes down to the essential oil content. And again, T4 delivered, producing a really high concentration of 0.83%. That makes the harvest not just big, but valuable.
Okay, this is the moment of truth. Let's put our compost champion, T4, right up against the chemical fertilizer. Look at this data. In what is arguably the most important measure, fresh weight, compost didn't just compete, it won. By a lot. And in the other areas, like height and essential oils, it was right there, incredibly competitive, practically neck and neck.
So what's the bottom line here? It's that compost, when you use the right amount, can give you a harvest that's every bit as good as what you get from chemicals, and in some ways, even better, all while healing the soil instead of harming it.
So, this is about way more than just basil, right? Let's zoom out and think about what this one experiment could mean for the future of farming and really for the health of our whole planet.
The researchers themselves put it perfectly in the study. They said compost helps store carbon in the soil. That's a huge deal for fighting climate change. And it also helps lock away nasty stuff like heavy metals so they don't get into our food. It's doing double duty.
And this is just a perfect real-world example of what people call a circular economy. Instead of throwing stuff away and creating waste, we're taking things like food scraps, turning them into compost, and cycling them right back into the system to create something valuable. It's brilliant.
So let's just recap why this is such a big deal. 1. Compost isn't a quick fix. It's a long-term investment in our soil. 2. It can go toe-to-toe with chemical fertilizers on yield without all the nasty side effects. 3. It's totally safe. The study showed heavy metal levels were way below safety limits. And 4. It turns a waste problem into a powerful resource. It just closes the loop.
And that really leaves us with one final big question. We have a tool right here that can heal our soil, cut down on waste, and grow amazing, healthy food, all at the same time. This whole experiment proves that we don't have to choose between feeding our world and protecting it. So, what are we waiting for?